In this lesson, we're going to learn how to write the equation of a circle, and we're going to learn how to work with that equation to plot circles and figure out equations of circles. So the way we did equations of lines is we used the fact that because of similar triangles, the slope of a line is always the same given any 2 points on the line. We're going to use a similar approach with circles. First, we're going to start with the definition of a circle, geometric definition, which is that the distance from the center to any point on the circle is always the same. We're going to use this fact to derive an equation of a circle, which is an equation that the coordinates of any point on the circle will satisfy, will make true. So for our first example, let's start with a circle centered at the origin and with radius 6. Let's practice first. Let's look at the point 5, 3, right there. It looks like it's inside the circle, but let's check and make sure just in case. We know the circle has radius 6. What we're going to do is we're going to use the Pythagorean theorem to compute the straight line distance from the center of the circle, which is at the origin, to the point 5, 3. And since it looks like that point is inside the circle, that distance should be less than 6. Let's check. Here's our right triangle. We know the x-coordinate is 5. We know the y-coordinate is 3. The distance we're interested in is the hypotenuse. So Pythagorean theorem, if we label this hypotenuse c, Pythagorean theorem says c squared is 5 squared plus 3 squared. And doing a bit of arithmetic, we get that c, this distance from the center of the circle to this point 5, 3 is the square root of 34. That's a little bit less than 6 because 6 times 6 is 36. So that tells us this point actually is inside the circle as it appears to be. Now suppose we have a point that's actually on the circle x comma y. So its coordinates are going to be x, y, and we know ahead of time that it is on the circle. We do know the circle has radius 6. So we can again use the Pythagorean theorem to write down an equation that this point or any other point on the circle must satisfy, and that is the equation of the circle. And basically we're going to do the same thing again. We know the hypotenuse now is 6 because we know that this point is on the circle. Because its x-coordinate is x, and because its y-coordinate is y, when I roll out the Pythagorean theorem on this triangle, I get 6 squared, that's the hypotenuse squared, is x squared plus y squared. 6 times 6 is 36. So we get this equation, x squared plus y squared equals 36. And this equation must be true for any point on the circle, even if x and y are negative. Because look, we're squaring x and squaring y. So the fact that x or y has a negative coordinate won't have any impact in this equation. This is what is meant to be the equation of the circle. Every point on this circle will work in this equation. So that is the equation of this circle. If x is any point on the circle, then its coordinates must make this equation true. In fact, with circles, we can do a little bit more. If a point is inside the circle, then if we do this x squared plus y squared on this point, we'll get less than 36. And if it's outside the circle out here, and we compute x squared plus y squared, we'll get greater than 36. Let's try this. If I look at the point minus 4, 4, that certainly looks like it's inside the circle. Let's check by plugging it into this equation. So when I plug minus 4, 4 into the equation, I have my equation x squared plus y squared is 36. I put minus 4 in for x. I put 4 in for y. 16 plus 16 is 32. That's less than 36. So that tells me that this point, negative 4, 4, is inside the circle as it appears to be. So now we're going to try to generalize this. We use a specific radius of 6 and a specific center of 0, 0. Let's see what we have to do to modify our equation so that we can use any radius and any center. Replacing the radius of 6 is pretty straightforward. Our original equation was x squared plus y squared equals 36. But 36 came from squaring the radius. So if I have a different radius r, I want to replace 6 squared with r squared. And that gives the equation of any circle with its center at the origin. And this is something you should memorize. X squared plus y squared equals I squared. It is essentially the Pythagorean theorem, because that's where we're getting this from. We're computing the distance from 0, 0 to xy using the Pythagorean theorem. So if we had a circle with radius 10, we would have 10 squared here. X squared plus y squared equals 10 squared. Or you could write that, of course, as x squared plus y squared equals 100. A little trickier, though, is what if I want to move the center from 0, 0 to some other point? Now, for reasons I don't know, traditionally the variables that are used to represent the center of the circle are h and k. So I'm going to stick with that because you'll probably see that again going forward in the future, although I would prefer to just use a and b. So let's use Pythagorean theorem again, going from the center to xy, and we know the radius is r. Now, what makes this harder is before, this was the origin, and so this was just the x-coordinate, and this was just the y-coordinate. But now, this is not the origin. So we're going to take inspiration from what we did with lines. We're going to call this a change in x. We're going to call this a change in y, because that's what it is. This is a change in x. This is a change in y. That is this distance, the change in x, and this distance is a change in y. So if I throw the Pythagorean theorem at this, I get the change in x squared plus the change in y squared has to be the radius squared. But thinking back to what we did with lines, the way we get changes is by subtracting. So we're going to subtract so that the variable x and the variable y are first. And so I will replace delta x with x minus h, and I'll replace delta y with y minus k, and I get what is called the standard form equation of a circle. X minus h squared plus y minus k squared equals r squared. When you're writing one of these equations, x and y should remain as your variables. H and k are replaced with the center of the circle, and r, of course, is replaced with the radius of the circle. Let's practice. First, let's write an equation of the circle that has center negative 4, 9 and radius 2. The radius is 2, that is represented by r. The center, negative 4, 9, is going to be represented by h and k. So I'm going to replace h and k with negative 4 and 9, like so. I'm going to replace r with 2. And then I just do a little bit of a simplification. Minus a negative 4 is plus 4. I can leave this alone. 2 squared is 4. Notice we are not going to be squaring this out. We're going to leave this as x plus 4 squared and y minus 9 squared. That is the equation of this particular circle. All right, let's try drawing a circle from its equation. Let's sketch the graph of the circle with this equation. So we need to read this equation and figure out what the center and what the radius are so that we can draw it. Since we have x minus 2 here, the x-coordinate of the center is 2. If I compare this form with the equation that's given, I see h has been replaced with 2. Likewise, I have y minus k in the form. I have y plus 4 in the given equation. So that means k has been replaced with negative 4. So that means the center of the circle is 2 minus 4. And then finally, this number here is r squared. It's already been squared. So we have to take the square root of this number to figure out the radius. In the equation, you're seeing r squared. In the graph, you want r. So how do I draw this with some accuracy? What I usually do is first I plot the center. Center is 2, negative 4, so there it is. And then if I'm drawing by hand and I don't want to get out a compass or fancy drawing tool, since the radius is 4 and I am using a coordinate grid, I go out and I plot points 4 in each direction, up, down, left, right from the center. Because I know this point has to be on the circle, it's 4 away. This point has to be on the circle because it's 4 away. This point has to be on the circle. This point has to be on the circle. And that provides 4 guidelines. And then I can, of course, I use Desmos here, But if you're drawing freehand, these 4 points gives you a guide to draw a reasonably accurate freehand circle. Your circles don't have to be beautiful, but they have to convey that you understand what the center of the circle is and what the radius of the circle is. Last example. This one's a little bit trickier. Let's determine an equation of the circle given this center and the circle that passes through this other point. So if I look at the form here, I was told the center. What I need to write down the equation is I need to know the coordinates of the center and I need to know the radius of the circle. So the coordinates of the center were given. 1, -8. Don't mix these up. The center is this point. This is some other point that happens to be on the circle. So right here, this is the center. So this is my h and my k. So I can plug in h equals 1 and k equals -8. And I get a partial answer. X minus 1 squared plus y plus 8 squared. But I still don't know the radius. I have to know this number too to finish the circle, or to finish the equation of the circle. Now, I could draw pictures and use the Pythagorean theorem. This is the center. This is some point on the circle, and I could draw out a Pythagorean theorem to figure out the radius. But don't we already have that here? This is the Pythagorean theorem that works for this circle in particular. So we're going to do something quite clever. Since -1, 2 is on the circle, we know that it satisfies this equation. We can plug -1 in for x and 2 in for y, and we get a true equation. And the only unknown in that equation will be the thing that we're missing, will be the r squared. So when I plug in -1 for x, I get -1 minus 1 squared. When I plug in 2 for y, I get 2 plus 8 squared. So this is -2 squared, which is 4. This is 10 squared, which is 100. And then 100 plus 4 is 104. And r squared is the number I need to put right here to finish my answer. I don't need to get the square root of this unless I'm going to draw it. R squared is 104. That's the number that I need right there. So here's my final answer. X minus 1 squared plus y plus 8 squared equals 104.